You were never taught the truth about Jupiter. In school, they called it the gas giant, the big, friendly planet with the pretty, swirling colors. They put it on posters, they named chocolate bars after it. What they didn't tell you is that Jupiter has killed before, and if things had gone slightly differently 4.5 billion years ago, you wouldn't exist right now. Not your country, not your planet, not your species, nothing. Stay with me because by the end of this video, the way you look at the night sky will never be the same again. We are going to cover 5 things NASA doesn't put in the headline bulletins. The magnetic field that makes our own look like a toy, the pressure that turns gas into metal, the gravity that decided which planets got to exist, the moons trapped inside a radiation prison, and the one event in 1994 that showed us exactly what Jupiter is capable of. Let's go. First, you need to understand what you are actually looking at when you see Jupiter. Most people hear largest planet in the solar system, and they picture something maybe twice the size of Earth, 3 times maybe. Try 1,300 times. You could fit 1,300 Earths inside Jupiter and still have room left over. Every other planet in the solar system, Mercury, Venus, Mars, Saturn, Uranus, Neptune, take all of them, stack their mass together, Jupiter still outweighs that pile, twice. But here is what keeps scientists up at night. Jupiter almost didn't become a planet. If it had gathered just 80 more times its current mass during formation, something would have switched on inside its core. Nuclear fusion, the same process that powers our sun. We would have had 2 stars. And Earth? Earth probably never forms in a 2-star system. The gravitational chaos would have torn the inner solar system apart before a single drop of water could pool on any surface. We exist, literally, because Jupiter fell slightly short, and what we got instead might actually be more dangerous than a second sun. Look at Jupiter's surface. That is not weather. That is violence, operating on a scale our planet cannot produce. That red oval you have seen in every textbook, that is a single storm, one storm. It has been continuously raging for at least 400 years, possibly longer. We don't know when it started because it was already there when we first pointed telescopes at the sky. And it is wider than planet Earth. Wind speeds at the edges of that storm exceed 400 kilometers per hour. Scientists describe that as calm by Jupiter's standards. Deeper in the atmosphere, jet streams are moving at over 600 kilometers per hour, faster than the speed of sound on Earth. These are not gusts, these are permanent walls of gas that have existed for centuries. Now here is where it gets deeply strange. Go deeper into that atmosphere. Keep going. At a certain point, the pressure becomes so extreme that hydrogen, the lightest, most basic element in the universe, the gas stars are made of, stops being a gas. It becomes liquid metal. Liquid metallic hydrogen. It conducts electricity like copper wire. It flows like water. And it exists inside Jupiter in quantities so vast that it generates something that should genuinely concern you. Jupiter's magnetic field. Earth has a magnetic field too. It's the reason life exists here. It deflects deadly solar radiation, protects our atmosphere, keeps the planet habitable. We owe everything to it. Jupiter's magnetic field is 20,000 times stronger than ours. If you could see it with your naked eye right now, it would look larger than the full moon in the night sky. It stretches millions of kilometers in every direction, so far that it actually reaches Saturn's orbit. It is the single largest structure in the entire solar system, and it is completely invisible.
But here is what makes this terrifying rather than impressive. Jupiter's magnetic field doesn't protect, it traps. It captures charged particles streaming in from the sun and accelerates them, faster and faster until they are moving at nearly the speed of light. Those particles form radiation belts surrounding the planet, and those radiation belts would kill you. Not eventually, not after prolonged exposure, in minutes. When NASA sent the Juno spacecraft to Jupiter, engineers built a special titanium vault, 200 kilograms of solid metal, just to protect the electronics. And even with that armor, Juno can only make close passes for a few hours before it has to retreat. The Galileo probe dove directly into Jupiter's atmosphere. Before it was crushed and vaporized by the pressure, it absorbed a radiation dose equivalent to 25 million dental X-rays. This planet does not tolerate visitors. But radiation is just what Jupiter does to spacecraft. What it does to the solar system is something else entirely. Jupiter's gravity is so dominant that it has been rewriting the rules of this solar system since the beginning. Scientists believe that early in our solar system's history, Jupiter didn't sit where it sits now. It migrated, drifting inward, closer to the Sun, bulldozing through the material that was trying to form planets. This is called the Grand Tack hypothesis. According to this model, Jupiter drifted as close as Mars' current orbit before Saturn's gravity eventually dragged it back outward. And during that migration, everything in its path was either destroyed, absorbed, or flung away. You know the asteroid belt, that ring of rocks orbiting between Mars and Jupiter? Those are not fragments of a planet that exploded. They're the building blocks of planets that never got the chance to form because Jupiter kept destroying them before they could grow. Mars was supposed to be bigger, possibly as large as Earth. Jupiter wouldn't allow it. And this gravitational destruction didn't stop in the early solar system. It is still happening. In July 1994, astronomers watched comet Shoemaker-Levy 9 get captured by Jupiter's gravity. The tidal forces tore it into 21 separate fragments. Then, over 6 days, those fragments slammed into Jupiter one by one at 60 kilometers per second. The scars left behind were larger than Earth. The energy released was equivalent to millions of nuclear weapons detonating simultaneously. If that comet had hit Earth instead of Jupiter, we would not be here right now having this conversation. At this point, you might be thinking, okay, but what about the moons? Europa has a liquid ocean. Scientists say it might harbor life. Surely the moons are safe. They are not safe. They are prisoners. Io, Jupiter's closest large moon, is the most volcanically active body in the known universe. Not because of its own internal heat, because Jupiter's gravity grabs it and kneads it like dough, over and over every single orbit. The tidal stress is so extreme that Io's surface is in a constant state of eruption. It rebuilds itself every few years. Europa sits inside Jupiter's radiation belts. The surface of Europa would kill you faster than the vacuum of space. Any spacecraft we land there will need to drill through kilometers of ice just to reach water shielded from the bombardment above. Ganymede is so large it has its own magnetic field, the only moon in the solar system that does. And even that is not enough to fully protect it from Jupiter. These moons, including the ones we dream about finding life on, exist inside one of the most hostile radiation environments in the solar system. They orbit a monster, and they cannot leave. So why do we keep sending spacecraft there? Because the most terrifying things about Jupiter are also the most important things we can study. That liquid metallic hydrogen interior could teach us how gas giants form everywhere in the universe. Jupiter's radiation environment is a live laboratory for physics we cannot replicate on Earth. And its moons, hostile as they are, remain some of our best candidates for finding life beyond this planet. NASA's Juno mission has been orbiting Jupiter since 2016. What it has sent back has completely changed our models. Jupiter's core is not solid, it is fuzzy, a diffuse, spread-out region that may still be absorbing debris from ancient impacts billions of years ago. The storms don't just exist on the surface, they extend hundreds of kilometers deep into the planet. And Jupiter's auroras, the largest light shows in the solar system, are powered by volcanic material from Io, ionized and guided along magnetic field lines into glowing curtains at the poles.
Here's the thing I want you to carry with you after this video. Jupiter has existed for 4.5 billion years. It was ancient before the first cell of life formed on Earth. It will still be there, unchanged, violent, indifferent, long after humanity is gone. In all that time, it has not once stopped being deadly. The next time you're outside on a clear night, look for the brightest, steady point of light in the sky. That is probably Jupiter. And when you see it, really see it, remember what you are looking at. A storm older than the dinosaurs, a radiation field that would end you in minutes, a gravitational force that decided which planets got to exist and which ones didn't. Jupiter is not the king of the solar system because it earned respect. It is the king because nothing else survived long enough to challenge it. If this video gave you a new way of seeing our solar system, subscribe. There's a lot more where this came from.